Glass is everywhere around us, from windows and mirrors to smartphone screens and drinking glasses. But have you ever heard that glass is actually a supercooled liquid? It might sound unbelievable, but it's a common claim that has fascinated scientists and the public for years. Today, we're diving into the science behind glass, its strange molecular structure, and whether it's truly a supercooled liquid or something else entirely. Let's get started. First, let's break down what we mean by a supercooled liquid. In simple terms, a supercooled liquid is a substance that has been cooled below its normal freezing point, but hasn't formed a solid crystalline structure. Instead of becoming a regular solid, its molecules remain disordered, like in a liquid, but they don't float easily. So people argue that glass fits this definition because, unlike most solids, it doesn't have a neatly arranged atomic structure. But does that really mean it's a liquid? To understand why glass is so unique, we need to look at how it's made. Glass is typically formed by heating materials like silica, soda ash, and limestone to extremely high temperatures, around 1700 degrees Celsius or 3092 degrees Fahrenheit, until they melt. When this molten mixture cools down, it doesn't crystallize like most solids. Instead, the molecules get frozen in place in a disordered state, similar to a liquid that has stopped moving. This lack of an organized atomic structure is why glass is called an amorphous solid, a material that has properties of both a liquid and a solid. One of the biggest reasons people think glass is a supercooled liquid is due to an old myth about medieval cathedral windows. You may have heard that the glass in ancient stained glass windows is thicker at the bottom, supposedly because the glass has been slowly flowing downward over centuries. It sounds like solid proof that glass is a liquid, right? Well, not exactly. Scientists have tested this claim and found that glass at room temperature is far too rigid to flow, even over thousands of years. The real reason old windows are uneven is because of how they were made. Glass-making techniques in medieval times were not as precise, so the glass was often installed with the thicker side at the bottom for stability. If glass isn't a liquid, then what is it? Scientists classify it as an amorphous solid, which means it has the rigid shape of a solid, but the disordered molecular structure of a liquid. The molecules are locked in place, but they didn't arrange into a repeating crystal pattern like most solids do. This makes glass different from both traditional solids and true supercooled liquids. One way to test the behavior of glass is by heating it up. If you raise the temperature of most crystalline solids, they'd melt at a specific point. But glass doesn't have a precise melting point. Instead, it softens gradually as it heats up. This gradual transition is called the glass transition, and it's another reason why glass behaves differently from regular solids. Scientists describe this behavior using a special concept called viscosity, which is basically a measure of how easily a material flows. At room temperature, glass has such an extremely high viscosity that it's effectively a solid in practical terms. So if glass doesn't flow like a liquid, why do people still call it a supercooled liquid? The truth is, this idea comes from early scientists who didn't have the tools we have today to study materials at the atomic level. For a long time, glass didn't fit neatly into the definitions of solid or liquid, so calling it a supercooled liquid was an easy way to explain its unusual properties. However, modern research has confirmed that glass behaves more like a solid than a liquid, even though its molecules are arranged randomly. But glass isn't the only amorphous solid out there. Many plastics, gels, and even some types of metal alloys have similar disordered molecular structures. These materials don't have a clear melting point, and they share some of the same properties that make glass so unusual. In fact, scientists are still trying to fully understand the nature of amorphous solids, and research into glassy materials is leading to exciting new discoveries in technology, material science, and even space exploration. So, what's the final verdict? Glass is not a supercooled liquid. It is an amorphous solid, meaning it has the structure of a liquid, but the rigidity of a solid. While the myth of flowing glass is fun to think about, real science shows that glass is stable and doesn't move over time. Still, its unique molecular structure makes it one of the most fascinating materials on Earth, with uses ranging from everyday objects to cutting-edge scientific advancements. Now that you know the truth about glass, let me know in the comments. Have you ever heard the myth about old windows flowing over time? What other material mysteries would you like to learn about? Don't forget to like, comment, share, and subscribe for more videos. Until next time.